Hello, my name is Olivia Irvin, and today I will be presenting my research on the effects of extra strength Tylenol, in which the active ingredient is acetaminophen on glycogen phosphorylase B. Various kinetic assays were completed to determine how an effector either activates or inhibits this enzyme. Absorbance was measured at 600 nanometers to determine the effects or the amounts, of inorganic phosphate that was produced in a specific reaction. For example, an effector could inhibit the enzyme through allosteric effects and prevent it from breaking down more glycogen into glucose and then inorganic phosphate. So in an inhibition reaction, we would see less absorbance. And to compare the effects of my effector, acetaminophen, on glycogen phosphorylase B, the effects of AMP and caffeine were examined first, and this provided comparative examples for when the acetaminophen was later tested. And I chose acetaminophen because of the similarities between caffeine and acetaminophen. You can see this through the molecular formulas, in which caffeine has one more hydrogen, three more nitrogens, and there are structural similarities as well in terms of their both molecules being cyclic. And this led me to hypothesize that given whether caffeine was an activator or inhibitor, then acetaminophen would have the same effects on the enzyme. So to begin, I first examined or created an inorganic phosphate standard curve along with a standard curve with no AMP in order to determine or compare whether having no AMP or AMP, what the difference would be. Unfortunately, the AMP graph or data did not come out with a specific conclusion of whether AMP acted as an activator or inhibitor, although it was expected to act as an activator. This was likely due to human error. However, when it came to the caffeine trials, these were successful and they determined that the caffeine did act as an activator, which was expected. However, this was not observed in the 4 millimolar trial. However, this was due to the caffeine resolidifying whenever it was added before the assay. And you could see the effects of it being an activator through the increasing Vmax. Finally, this leads me to my kinetic assays of acetaminophen. On graph F, which is here, you could see that it acts as an activator when there's more acetaminophen. Whenever there's essentially less AMP, you're going to see an increase in the Vmax, which signifies an activator. However, on graph E, whenever there's a greater concentration of AMP, you cannot see the activating effects of the acetaminophen. So these results were inconclusive in terms of determining whether it's an activator or inhibitor. However, because there is an increase in the absorbance here, as you can see on the orange line, this signifies allosteric effects. So overall, as I had originally hypothesized, acetaminophen does have an activating effect similar to caffeine. But however, I would lastly like to acknowledge and thank the Department of Molecular Biosciences for their support, along with Dr. Roberto de Guzman, Dr. Constance Halberg, my graduate teaching assistant, Saida Nasiri, and my partner, Jamie Loggins. Thank you.